So we're actually not just going to stop at writing half equations. We're going to also balance them. So first thing you always do is write out the oxidation numbers, and then you can tell by the oxidation numbers which ones are the spectator ions, and then you can remove them and make sure you label which one's the reduction, which one's the oxidation. So let's just do that. So this is the problem here. So we write in the oxidation numbers. So they're in the normal states, -1, so that must be +2, just following the oxidation rules. We can see here that copper must have been reduced. Magnesium's that's gone down. Magnesium has gone up, so it must be oxidized. And these two didn't change, they're the spectators, so we can remove them. Okay, so chlorine's a spectator ion, and which one's oxidized reduced? So we rewrite them. So there we've got magnesium to Mg2+, Cl, so copper to Cu2+. These are assumed aqueous, so that's assumed solid. And then we can balance for electrons on both sides, and then we just add them together. Oh no, we're not adding them together yet. Sorry, we will get there. Okay, so balance for electrons and add states, and there we go. We've got our two half reactions, okay? And those ones are all done and dusted, actually, so you're good to add those together. But we're going to do more complicated ones. And so this is the system you're going to use, because some will be easy, some won't. So you might need all of these things. So I've just tried to summarize it in red. So this, you don't have to actually follow this here. You can actually mix this around, but this is the most logical, okay, and causes less hassle. You could swap a few of these around. So write the oxidation numbers. That'll tell you which one's oxidized, which one's reduced. Choose which one you're going to do. You have to do this twice now. So step 2, 3, 4, 5 is going to have to be done twice for the two half reactions. Balance for the elements that are oxidized and reduced. Then balance with the oxygen with water. You don't have to do basic. If you did, you'd be balancing with our H minuses, which can get really tricky. And then balance for hydrogen ions with H plus, and then add electrons and states, and you're done. Sorry, that's half reaction. So yeah, add states as well. Okay, so balance ion here. So this one's skipping most steps because it's already done already. So the oxidation states are not done, but they're pretty easy to do. The ions already balanced. There's no oxygen and hydrogen. Skip all those steps. So you just have to balance the electrons. There's a 2+ and a 3+. So if you add electrons on there, both sides are 2+. So we're done. Just add in the states. Ions are aqueous, and we're finished. Okay, let's do something a little bit harder. All right, so this one here is much harder. So we've got +2, fine. -8, -2, so that's a total of -8. Must be a negative charge, so it must be a total of +7. There's only one of them, so it's +7. So it's +7 to +2. I forgot to tell you, you've got to tell me what it is. And so that is reduced. I didn't write that out, but we will when we do the proper balancing. So that's the reduction one. So the elements are balanced, so we can actually skip part 2. Part 3, we're balancing the oxygens. There's 4 there, so we need 4 waters to balance for the oxygen. Now we balance for the hydrogens. It's a total of 8, so we put 8 H pluses. Now we balance for electrons. So this adds up to a total of 8 plus, and this one only adds up to 2 plus. 2 plus. So we need to put another, 2 plus, 8 plus, and there's a minus there. Oops, it didn't add up because the answers didn't add up. That's cheating. So +7 over here because there's a 1 minus here and 8 pluses here. Okay, so 8 minus 8 plus 8 minus 1 equals +7, and that one gives us the +2. So +2 and +2, we need a -5, so that's where we get our 5 electrons, and now they're both 2+ charge on either side. Okay, so that is balanced to the electrons, and so we're done. Add in the states, but the ions is aqueous, water's liquid, no solids forming. Okay, and that's it, balanced. Okay, doing another one. Okay, so again, that one's oxidation state's fine. -2 gives a total of -14. It's overall -2 charge. I must need a +12. There's 2 of those, so it's +6. So that is a reduction half equation. This time I have to balance for there's 2 chromiums, but there's only 1 over there, so I put a 2 in there. I need to balance for the oxygen, so I need 7 waters to get the oxygen, and now I've added 14 hydrogens, so I've got to throw them on that side. So now I need to get 14 minus 2, I need to get a total of plus 12 on both sides, but I've only got 2 times 3 plus, I've only got 6 plus, so I need 6 electrons here. To make them a total of 6 plus. So I throw 6 electrons in over there. It should all balance out. Just re-add the states in and I'm done. Okay, so do a few practice ones of those. And then you've got to put them both together. So you can see how bad this is. You had to do all the previous work. And now I've got to put those 2 together. So first of all, you get the electrons to cancel out. So there's 5 here and only 1 there. So I need to times the top one all by 5. That allows me to get rid of the electrons. And then I can also get rid of anything else that's a repeat on both sides, cancelling out. But that doesn't happen there. So I'm sort of finished there. Just do a Hess's law and add them all up. And then just re-put the states in. And there's your fully balanced redox reaction. So do a few of those. They do take a while. There's a lot of little things to do.